Okay, well, today we're back to CBs. It was turning business radios into ham radios yesterday, and today it's Monday, which is actually Easter Monday. But when you're self-employed, nobody gives you any time off, do they? So you have to carry on. Well, this is coming in Maxcom 30E, and it looks like it's been beautifully resprayed, rather than it being always beautiful condition. And it's got some bump-ons to use it as a base station. Got a label on the top. Can you replace the power lead to the original type? Yes, we can. That'll get passed on to Mr. Chippy, and it's from, what's that, 1988. He's also sent a copy of the instruction book blown up to A4, and any of you who know the Maxcom products of this era will know that you got not only the circuit diagram and the layout, but you also got the alignment instructions as well. So it's half a service manual, which is great. He says I may keep that. It's better than the copy we've got. So this white balance doesn't look right. It's just oh no, it's just the angle I was on. Right, so we'll take the screws out and see what we're greeted with. When you get something as immaculate as this, it would be just typical for the screwdriver to slip, wouldn't it? This is the same customer as we did that Midland 48 early version, the 1999 PR2797 with the meter that didn't work. The meter still doesn't work because he's chosen not to pay an arm and a leg for a new one. Somebody said, isn't that the same meter as used in the Precision series? And of course the answer is yes, it's the same meter as this as well. In the old Midland Precision series. But, you know, unless he finds an old Midland Precision set, you know, we're still stuck. When we buy scrap chassis, they don't have meters. Somebody has those and sells them on eBay. And like, you know, if you took your car to a garage, you wouldn't want them to be putting second-hand parts in. So that's what we do. Wherever possible, it's new parts or the customer's given options. So I'll unsolder the speaker. They've got green to the left. We'll check the polarity. That'll, not that it matters, but we could still check the polarity. So I can't see anything naughty in there, which is something I have to check for. The S-meter calibration preset potentiometer is an option on sets like this, and it's there on this one. What's happened there? Is that the way the chokes are? Change his glasses. And let's hope when we get into this video that picture-in-picture actually works today. Yeah. And will we have an antenna warning indicator that actually works today? So we'll service this as presented with the wrong type of power lead. Then I'll get Mr. Chippy to change the socket on the radio, and I better make sure the customer's actually got the power lead to go with it. But it's a sensible thing to do to restore it to how it should be. I don't think anybody's messed that up. I don't think it doesn't look like it's not going to accept the correct socket back, you know, because you're always scared that have they had the file to it or worse. So the polarity is correct for our lead. So I've got the positive to my left, and the red wire on the radio is there. Good. So hopefully, yep, it switches on and it comes on channel 20. So we'll make sure these are at full, PA, filter out, in DX mode and on 4 watts. And now we'll connect it up to the test equipment. First of all, I'll put that loudspeaker one in. basically it's the same, basically the same board as you got in the Midland Precision series and the Maxcom 4E, etc. at the time, but with a crystal filter on receive. I don't know if the background music's coming through. It shouldn't be as loud as this, but it is. I don't know why that is, but it's Gilbert and Sullivan, so if you're into operettas, that's what's on the background music system, as it is at the moment. Totally random. I'll make you all smile though. I'm going to zoom in on this chip, because you hadn't heard of this firm at this time. Not many of you anyway. Right. See, there's an LM324 chip just there. We've got that yellow wire in the way. You see the logo for Samsung? See, Samsung were a component manufacturer for donkey's years. Before they started making, well, we had the television shop in Yorkshire, and they were doing, they started sending over black and white portable tellies, was it the BK309, and they were reliable. And they were kind of the first Samsung products we saw, probably about 1983. But they were making semiconductors years before that. These are made by, radios are made by Maxon, and they called them Maxcom, didn't they? And I used to do Maxon business radios when I was service manager at Nottingham Radio. And one of the things they said is they took a colossal amount of Motorola semiconductors, and you'll see the MC3357 IF subsystem chip there is Motorola, and Maxon took something like, it was something colossal, like 16% of Motorola's global semiconductor output, and produced something like 86% of the world's CB radios. And, you know, they used to say, well, and if you think that's a naff market, you know, it's so many $1 billion, you know, when you're looking at the world's. But, of course, it all seems to have been lost to China, doesn't it, these days? And, yeah, these sets plod along. Right, so we can hear it receiving. Do these receive with no mic connected, then? Obviously. So we haven't been sent a mic with it. We're not really encouraging mics with the coronavirus situation. So I think this one could well be, I'll just return the camera to its normal position. Just like that. I sensibly have its zoom set up in the memory of the camera. So if I plug that in and go into transmit and select picture in picture, which is showing on my monitor, I'm going to stand up. Yes, it's showing on my monitor. Right, we'll key up. I'll put the test that in the 3-watt mode. Wow, bang straight across. Radio spot on 4 watts. Well, we don't often see that, do we? Wow. Certainly not. If it was a news set, we wouldn't be seeing that. So I'm going to get a piece of paper. We'll write down what the radio's doing, because there's nothing worse than fixing it worse. I got that phrase from I took a starter motor for a Datsun 720 pickup truck that I owned in the very early 80s. And the starter motor packed up on it, and I took it to a local shop in Nottingham for them to rewind, whatever they do to them. And there was a bloke in there with a starter motor and alternator, and he slammed it down on the counter. He was obviously dissatisfied. He says, "You fixed it worse." That's a lovely phrase, isn't it? Fixed it worse. Maxcom 30E TX 4 watts. Deviation. Just have to reset my meter after doing 400 megs yesterday. Wallow. Whoa, it's 3.5. That's got to come down. And things like that can really restrict your range. You know, it's not like AM where more modulation is better. It ends up with it, the fat guy not going through the narrow door and it chopping bits off. So it's not good at all. Unless, of course, you've got a Fidelity 1000. Actually, I had a question on the comments. I've got a Intec 899 and loads of people sound off frequency. Well, they are off frequency because they're using illegal radios. And, you know, whether you like it or not, all those sets that pretend to be 28 meg ham sets but are really masquerading as illegal CB radios, is it a something 6690? Is it CRT do it? You know the kind of things. They're not type approved as CB radios. They are masquerading as the 28 meg ham. They're sold as 28 meg ham sets to get through some legislation, but they are really illegal CB radios. They're not type approved, and the people who are using high power ham radio equipment like Kenwood and Icom and Yaesu on CB frequency, it's totally illegal. Nobody can do that. Radios have to be type approved. And, you know, people doubt me saying these kind of things. Well, just check with Ofcom. I'm not telling you wrong. So they are off frequency. So don't throw away your intake set. It's the people who are off frequency who are doing what they do, and no doubt talking to the mates who are similarly equipped and also off frequency. So, yeah, we get it here. And of course, the better the set, the more off frequency they sound. So if you listen to these people on something like a Fidelity 1000, which is as wide as a barn door, these people come through beautifully. And that's when your 3.5 kilohertz will come through beautifully. You listen on a Fidelity 1000, it will sound great. You listen on something with crystal filtering, and that will be distorted. Right, rant over, and now we'll get on to seeing whether the frequency is anywhere near. So we should have 27.79125. Right, so we'll deal with that. We'll deal with that immediately because that's easy. So the trimmer next to the crystal. Shall we turn it to the left? Shall we turn it to the right? Let's go to the left today. Well, I hit it right for once. Oh, it's one of those, is it? There we are, 27.79124 toggling 5, so that's now corrected. We'll still have to go through the tune-up of the transmitter, but I don't. There's a thing in the service information as to how you drop the power if it goes over. So we've done that, and we'll just see where we are with the receive. So RX is 1. Let's put that on there. We're about at 12, and the radio is doing 0.78. And that's fine, but we can probably improve that. I don't check the VCOs unnecessarily on anything using the Maxon chassis if there's no reason to, because the wax is still in that coil, so there's no reason, it's not being messed with. And a lot of the Maxon chassis sets, the components which you need to read to get the VCO voltage are missing. And that is really frustrating. You know, you can end up having to add 4 parts which were never fitted to set the VCO, and I really don't want to be doing things like that. It wastes time. So VCO, it tells you what to do. It's 3.2 volts and at the test point. And out of interest, is the test point actually fitted on this one? We'll just check that. I'm not going to check the voltage, but is the test point fitted? Can't even remember where it's supposed to be. It's definitely the best copy of this I've ever seen. The test point is at the junction of capacitor 208 and resistor can't quite read it, and resistor 160. So we know 160 where that is. See 161. So it's there. So where capacitor 209 is and 160, and that is the test point. So we've got the coil, there's a varicap diode there, and we've actually got the top end of a resistor, and actually it is, I will read it, but I'm not going to alter it unless it was stupid. So basically, are these positive earth or are they, sorry, are these negative earth or are they floating? Just check. So the negative earth. So if we go on that test point there, we're on channel 20, we've got 2.9 volts, and they're wanting it to be between 3.2 and 2 volts over the range. So if we put it on channel 40, so there's channel 40, it's actually 4.2. But you know, this is all, what meter were they using? You know, is this reference to an electronic meter? Is it reference to something like an AVO 8? I don't know. And our transmit is 2.3. And if we go to channel 1, we've got 1.88 and 0.79. The point is it's in lock, and I'm not going to alter that. Right, we'll go back to channel 20. So we need to be adjusting L107, 109 and 108. 107, 109, 108. So we'll do those three, that's the first bit. So we're looking for peak. And we may as well use the ceramic tool seeing as we've got it. So it's actually about 4.1 at the moment. It'll probably drop down as the radio heats up. So that is peaked. Next stage is 111, 12, 13 and 15. 111, 111, which is 112 now. 112, 113. These are, they're wanting you to fiddle around with the with these fixed coils with a little bit of stretching, but or contracting, depending. Because the radio is doing 4 watts, we don't need to do that. And then 15, it's not ideal way of tuning them, but that's what they have you do. And then 10, 8 and 9 for peak power. So we go, it's 10, 8 and 9 for peak power. And if we go over 4 watts, you turn L15, 115 counterclockwise, which is that one. Is there a coil in there? Oh yeah. Until you get 4 watts. It says 3.8 watts, but we don't need to play that game of getting them through customs because they're already here. So, peak. Change tools. We've actually gained 0.1 of a watt for what it's worth. That's too stiff, so we'll just heat that up with the smouldering bat. So we've got about 4.2 watts there. You wouldn't say that with a modern set, would you? You know what? The core's missing out of that. There's nothing in there, and we need to have that in to vary the power. Now we're going to have a scrap one of these, and I think there's one really close by. There is. This is what I would say. The last thing you want to do is to be putting second-hand parts in a customer's set, but there isn't an alternative when it comes to special parts like coils. And this donor set is the remains of a Midland 2001. And that's the core that's missing from this. Probably somebody found if you took it out you got more power out of the set. Because that's happened, I'm going to have to check it with the spectrum analyzer, so I'll switch that on. Okay, so look, I'm doing all this and I've got the wrong meter on. As you can see, we've got 4.2, 4.3 watts. So we'll just turn this down. And I've already forgotten it's counterclockwise. So we're going to put this clockwise till its peak point. So we peak it, and that is 4 watts. So it's exactly the same power as it's come in, but by doing a tune-up it was actually capable of 4.4. Right, let's have a look at the what the spectrum analyzer says. So I'll press the auto button, and when I can find it, auto, there, key up the radio, switch to spectrum analyzer, and it's found it 2779 180. So there we go. That's that. So now we just need to look for the 54 meg thing. So I'll type in frequency, well, 55 megs. It's there. Let's measure that. Marker, peak. It's minus 48 dBm. So we'll just have a little fiddle with that. So that's there. Minus 53.9. It should be about minus 54, so that's fine. What I've done, I've had to alter that one slightly to drop that, and then adjust that one slightly. So if we look back at it was minus 44.7, so it was a bit naughty with that. So we're still spot on 4 watts, as you can see. There's our 5 watt, there's our 4, but now we've got it in spec on the interference. But read less on the Zetagi meter now. Talking of that, here's the Zetagi meter. Let's see how many Zetagi watts. Now we've cleaned it up, I would guess it's going to be 5.5 Zetagi watts. Right, place your bets. 4 real watts, or I'm about right, aren't I? Certainly above 5 on the Zetagi watts. Good. Now that pesky deviation, if that's what's next. I'll go through it in the order they've done it. Well, they haven't got 10100 in there. What a shame. What a rubbish Tenko. Right. Check the frequency. We've already done that. Check the sensitivity of the modulation. Well, of course, it's not modulation. It's keeping that value higher than 60%. What are they talking about? Anyway, they want you to set it to 2.2 kilohertz. So that's they want they want it to be 60% of 2.2 kilohertz. Yeah, right. Oh, see me working that out. So which preset's 105? 105, 105, 105. It's a few days since I did one of these, so I've totally forgotten. Don't know, is it that one down there? No, it's 101. So it's one of those up there? Yes, it is. It's the lower one. Okay. So we'll put this on our little generator. And we'll lower that from whatever it is. That's the wrong end. How come? Oh, I've got it on the power. Wallow. Spot on. 2.2 to 2.5. And the meter on the front wants to also say something round about 4. So let's have a look at that. It bangs across. Boing, says 10. Well, we'll set that to 4. Just remind myself which one it is. Is it that one in the corner or is it low power? Meter alignment is 103. That's 102. Oh, so meter 1 is the one there. So that's somewhere near. That'll be low power then, won't it? Well, it doesn't actually say. So 102 is that preset. So let's just see if there's any mention of that further down. No mention of it. So chances are it's going to be low power. So we'll select low power on the radio. It should be 0.4 of a watt. It's 0.55, and now I've got a sneaking suspicion. Yes, it is. It's low power. There we are. Bang on the 0.4 watt. How good's that? So a radio that does all the right powers is absolutely great. So we'll move on to the receive. It's 4:30 in the afternoon, so we're still all right. Switch that spectrum analyzer off. Receive T5678. So it's 5, 6, 7, 8. We're going to start with the detector, whether they say so or not. Experience with the Maxon chassis is out of all the things that will go out of alignment, then the detector or the FMD modulator or the discriminator, what you want to call it, that is the thing that goes out the most. So I'm going to put an S9 equivalent signal on the signal generator. We'll switch the oscilloscope on and we'll switch to the appropriate one. Somebody says, can we have more brightness on this? There is a way of turning more brightness on that, and that's by turning the bench light off. So let's just check we're on highest brightness. Just turn that up a tad, and here goes. But I'll use the metal tool. It's quite a big coil. So we're looking for maximum recovered audio with an S9 equivalent signal, which is 100 microvolts on a UK CB radio. There we are, no improvement whatsoever. So it was already spot on. Put the bench light back on and turn the oscilloscope off and save myself half a pence for electricity. So we're now turned down to a usable signal. That will do about 5 dB, and let's see whether we can get a bit more out of this receiver, because it was not as good as I think it could be. Oh, look at that. That's come up a mile. I've actually gone to my 0.3 microvolt minimum on the test set. That's more like it. I wonder if a screwdriver expert thought that was a transmit one. There we go. It was just the one which was out. So let's get a new reading for the cyanide. And we've now got 0.68. I'd have liked it under 0.5, but it isn't, and that's how it is. Let's just see where we are on 10. So it's 0.58 microvolts for 10 dB cyanide, and if it does 20, not all radios do, it's 2.5 microvolts for 20 dB cyanide. So you're measuring noise, so if it's got inherently noisy transistors because they're cheap, this is where you're introducing noise. I've said to you before, a friend of mine had a Hitachi stereo cassette deck, and unless you used the Dolby on it, the noise it generated from its own hissy transistors was unacceptable. Well, he didn't want to use Dolby, so it was useless, you know. So that was all down to noisy transistors. So we'll turn that down, and we'll just see what we can hear it down to actually physically hear it. So there's 0.3 of a microvolt, 0.25 of a microvolt. We can hear it down to about 0.2 of a microvolt. Of course, your noise floor is more than that, so it works fine. So it's on frequency, and although that was really neither here nor there and still in spec, it's still something which we've looked into and made right. So it's going to make a difference. I just wonder if this filter makes a difference. We'll go back to 12 dB cyanide, and I'll take a reading once again. Yeah, 0.68. We'll switch to filtering. So has that made it any better? It's about 0.64 with the filtering, you see, because it's cut the treble end, so it's knocked the noise down. So there you are. Right, the only thing to do now is the antenna warning indicator. And Dave up the road came with the best technique of this by using a antenna matcher. Now, is this the one that works, or is this the one that doesn't work? I'll have to go and get a dummy load. I'm going to momentarily key this up on low power with no aerial. And this meter's working, so I'll go and get a dummy load. We'll pause the video. There's a dummy load. Plug that into there. And now we'll go back to 4-watt power on the radio, and we can set this up. I'll tell you how we store this dummy load. It's plugged into a 300 watt MFJ dummy load. 300 watts is for about 20 seconds, by the way. It's not continuous by a long way, but when we're doing some of the ham radio sets that we've been doing of our own, because we don't do ham radio sets for customers, you know, that's what it was purchased for. But it should make you smile that we have the dummy load plugged into the other dummy load. So I'll just make sure this is in the off position, we're in power, we're in the 5 watt position, and I'll key this radio up. So we'll set that while we're setting. What am I doing wrong? No idea. Oh, it's in power mode, that's why. So it says... yeah, power 5 watt mode. I can't even see where the scale is, which says 5. If that's the case, it says it's about 5.8, which is probably about what it thinks. Anyway, we'll go into SWR mode. That's what I really wanted. So we'll set, reflect, and of course it's not that accurate, is it? It should read better than that because it's in a dummy load. So what we're going to do is switch the matcher on and generate a 3-to-1 SWR. Okay, 3-to-1 SWR now. So we'll just check. Forward. What's that one? Forward. Bit there. Reflect. 3-to-1 SWR. So what I want now to happen, and it may not work, I want the antenna warning light to come on. I don't see many of these circuits working, and it's not something I chase. That's another one that doesn't work. I'll just make this to be a bit worse. Oh yeah, so we've got making it to 4-to-1. The SWR warning light is now coming on. So I don't often see these working. So we'll set that up so that it does come on. So now I'll play with the SWR and I'll tell you what I'm doing. Just turn that back. So at the moment we've got 2.7 SWR, 3-to-1 SWR, it comes on at about 6-to-1 SWR, to be honest. So we'll switch the matcher back out and key it up as normal, and it reads without the antenna warning light coming on. So that's good. Out of interest, we'll plug our aerial into this SWR meter. It seems to be reasonable. Let's have a look. So it says we're about 1.8 SWR on our base aerial. Right. The radio is done. Now that will need to go over to Mr. Chippy's department to have that done, that power connector done. So I won't put it back together. What? No, but no 10 to 5. And nobody on? Well, Nana, Roger. Not a lot of traffic out there. Okay, well, we'll do an on-the-air test later on with that when... oh, we have not done the Squelch, have we? We never did the Squelch. Back onto the test set with it. If we live stream these, the viewers could say, "You've not done the Squelch." Trouble is, I have to do these in different sessions because of other work commitments. Right, so we'll turn the Squelch to full, and let's see when it comes in on the test set. And I'll switch that to the attenuator controls, so you can see the attenuator controls. I'll switch picture and picture back on. So 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts, 300 microvolts, 1 millivolt, 3 millivolts. It's one of those sets where the Squelch never comes in if it's on full. So that definitely needs adjusting, so I'm glad I didn't overlook it. It's RV101. Well, it was the only one left, wasn't it? So that just needs backing off. And that one's going forwards again. That's it. 100 microvolts and it's coming in. So that's where we want the Squelch to be. I'll take the tool out. Yep, it's still working. So now we'll just take the signal generator to the off position. Turn the Squelch down. Set threshold. Switch the signal generator back on. Parks at 0.3 of a microvolt. It nearly came in there, it didn't hold. Let's see when it comes in. Coming in at 0.52 of a microvolt, and it's leaving us at 0.21 of a microvolt. So that's fine. Right, I'll pass that across to Mr. C. Thank you for watching the Maxcom 30E.